Today's lesson is on similar polygons. So as usual, after we finish the lesson, I want you to come back and write your essential question. Two polygons, sorry about that. Two polygons are similar. And here's the notation for similar. It's the little top thing off of the congruence symbol, the tilde, I guess, if you will. So two polygons are similar if corresponding angles are congruent and the lengths of corresponding sides are proportional. So remember, we talked about proportions in the last lesson. For polygons to be similar, all the sets of corresponding angles have to be congruent and the lengths of corresponding sides have to be proportional. So you can see it here in this little diagram that I pasted in from your textbook. If this quadrilateral ABCD is similar to GHIJ, then I know all those angles. A is congruent to G, B is congruent to H, and so forth. And then the side lengths, the corresponding side lengths have to be proportional. So in other words, AB divided by GH has to equal BC divided by HI, and so forth. All right. The ratio of the corresponding linear measurements of two similar figures is called the scale factor. So if I look at what I was talking about up here, if I were to figure out, if I had numbers for each of those sides and I figured out what each one of those fractions is and simplified it, that would be the scale factor of the first figure to the second figure. Okay, so let's just do that here. Let's find the scale factor. Let's find the scale factor of triangle ABC to triangle XYZ. And it's given that these are similar. I already know that, so I know that, but let's see what the scale factor is. I've only got to do it with one set of sides, right? Since they've already told me by saying that these triangles are similar, that the ratio of every set of corresponding sides is the same. So I've only got to pick one set of sides. So why don't I just pick AB over XY? It doesn't matter which set I pick. I could pick any, but I'll pick this. So I've got 15 over 6, and of course I want to simplify that. 3 goes into 15, 5 goes into 6, 2. So there's my scale factor. The scale factor of triangle ABC to triangle XYZ is 5 to 2. Okay, now let's use what we know to decide whether these figures here are similar. And if they are, we're going to write down what the scale factor is and a similarity statement. Okay, first of all, let's check the angles. Well, I can see this one is congruent to that one's congruent to that one to that one, and that one to that one. So I've got the angles covered. So now what I have to see is whether FJ over KN equals FG over KL equals let me not switch, GH over LM equals HJ over MN. So I've got to see if all those fractions are the same. So what do we have? We got 12/9, and I should put question marks here because I don't know yet whether they're equal or not. So does 12/9 equal 8/6 equal 16/12 equal 20/15? I don't know. Let me simplify each one of those and I'll tell you. That'll be 4/3. 2 goes into 8. That'll be 4/3. That'll be 4/3. 5 goes into that 4/3. So yes, indeed, these are similar. And my similarity statement would be that FGHJ is similar. This is the scale factor, by the way. That is the scale factor. So FGHJ is similar to KLMN. There's our similarity statement. All right, why don't you pause right here and you decide if these two triangles are similar, and I'll be right back with you to check. Hopefully before you dove in there and started doing all those ratios, you said, wait a minute. I don't know that all the corresponding angles are congruent. Therefore, it doesn't do me any good to decide whether the side lengths are proportional or not, even though they aren't. But I can conclude right off the bat, because the angles aren't shown as congruent, the corresponding angles, that I can't make any conclusion about whether these triangles are similar. I don't want to say for my answer, well, actually, I do know they're not similar because of the scale factor. Their side lengths aren't proportional, so definitely I know that these are not similar. Okay. How about this? Ooh, some real life stuff. You want to make a scale drawing of New York City's Empire State Building. Using the scale, 1 inch equals 250 feet. If the building is actually 1,250 feet tall, how tall should your scale drawing be? Okay, so let me draw the building. Let's say this is the building. This is the Empire State Building. This is the actual building, because I have to draw a sketch. And it is 1,250 feet tall. Okay, let's see. My scale, here's my scale. Let's say this is my scale over here. And 1 inch is 250 feet. So I'm trying to figure out how tall I have to make this. So what I got to do is I use my scale, and watch this, guys. If I know that I told you before, I have to make all the units the same, but you don't necessarily have to do that when you're working with a proportion. So if I know that 1 inch is 250 feet, then now I'm going to hop in here. So this is my scale length, right? This is my scale. And this would be the actual. This would be the actual. So my other fraction has to be the scale, which is x. That's what I'm trying to find out. And the actual height of the building is 1,250 feet. So this is inches, this is feet. So when I cross multiply and then simplify and solve for x, the only unit I need is still going to be there, but look what I can do. If I switch my means, can't I make this problem a lot simpler for myself? If I switch my means, let me do that right here. I'm going to have 1 inch over x inches equals, the 250 is going to go up here, 250 feet over 1,250 feet. All right. So what I'm going to have here then is that 250, and then all my units are going to cancel out, right? So I'm going to have 250x equals 1,250. And then when I divide 250 into 1,250, I just get 5. And I know that x is in inches, right? X is 5 inches. Actually, it didn't do me a bit of good to swap this because I didn't simplify this here. You see that silly mistake I did? I switched my means, but then I didn't simplify this fraction here. That's what I should have done. I would have had 1 over 5. If I simplified this, it would have been 1 over 5. And then I would have directly gotten that x equals 5. But nevertheless, I got x equals 5 inches, and that's how tall our scale needs to be. All right, how about the flag problem? Why don't we pause here and you try to do the flag problem? Make sure you sketch your actual flag, the standard size flag, and the giant size flag, and see if you can set up a proportion to figure out what the length of the longer side is. Okay, let's see how you did. We drew our 2 flags. We know that the standard size is 3 by 5. 3 feet by 5 feet. All right, and the giant size flag, the shorter side is 36 feet, so clearly this is the side and I'm trying to find the length of the longer side, so we're going to call it x. All right, so now all that's left to do, guys, you got to have a picture. It makes this so much easier. So now I'm just going to set up my proportion. So I took my short side for each flag. 3 is to 36. 3 is to 36 right here, as 5 is to x. Could I have said 3 is to 5 as 36 is to x? Of course I could. I would have gotten the same answer for x eventually, but I like it this way because I can simplify 3/36 down to 1/12. I actually remembered to do it this time. And then my cross product doesn't even have to be simplified. When I cross multiply, I just get x equals 60, and don't forget your units. So that big flag there is actually 36 feet by 60 feet. That's a big flag. All right, how about the perimeter theorem? If two polygons are similar, then the ratio of their perimeters is equal to the ratios of their corresponding side lengths. In other words, if this KLMN is similar to PQRS, then I know that the perimeter of KLMN divided by the perimeter PQRS equals KL over PQ LM over QR MN over RS and NK over SP. And of course, all four of those ratios are going to be the same, so I could have picked any one of them, but I'm just illustrating the point. The ratio of the perimeters equals the scale factor. Ratio of perimeters equals the scale factor. Okay, let's see how we're going to put that to work. Pentagon CDFG, so this one right here, is similar to this one. All right, what is the value of x? Well, I know that x is to 2 as 9 is to 6. I could simplify 9/6, but this one's easy enough. I don't really need to do that. I get 6x is 18, so x equals 3. So my scale factor is 3/2, right? Well, no, I'm sorry, x is 3. That's what I'm looking for first. X is 3. My scale factor, I'm going to call it SF, is 3/2, 3 to 2. And then let's see, what else do they ask us? If the perimeter of the little one, so this one here, is 20, what is the perimeter of the large one? We'll call this P1, we'll call this P2. All right, so we're going to use the theorem that we just learned above. So we're going to take our scale factor, 3 is to 2, and remember, P1 is x, so we got to put it on the top. P2 is 20. So once again, I could switch my means and then simplify, but this one's simple enough. I really don't need to do that. I get 2x is 60, therefore x equals 30, which is P1. That's the perimeter of the first one. So see, I don't even have to have all the side lengths to know what the perimeter is. All right. We've got 2 more problems here. I want you to pause the lesson here, work these, and then come back and check. All right, let's see how you did. Verify that these 2 triangles are similar. All right, of course, the first thing I want to do is make sure that all the corresponding angles are congruent. Well, they have 2 marked, but I know that angle R is congruent to angle S because of the third angles theorem. Hope you didn't forget that. So check. All my corresponding angles are congruent. All right, now I've got to see if all the corresponding side lengths are proportional. So I set up my ratios of the sides, the corresponding sides, and when they're turned, funny, how do you know which sides are corresponding? What if the angles weren't marked? Well, what you would do is you would pick the short side of one and the short side of the other, the medium side of one over the medium side of the other, and finally the longest side divided by the longest side. So that's how you know which sides are corresponding if the angles aren't marked. Okay, and when I simplify those ratios, I do get 3/2, which means that all the corresponding sides are proportional. So triangle PQR is similar to triangle VT. Yes, I should have said write the similarity statement. You always need to do that. There it is. All right, and how about this problem? Parallelogram Jklm is similar to PQRS. Find the value of x. So we're going to set up a proportion to do that, and here it is. Here's my proportion. 20 is to 15 as 8 is to x. Simplify 20/15ths, you get 4/3. And then cross multiply, 4x is 24, you get x equals 6. Wrote that in for you there. Okay, so now we're going to use the theorem we learned today to figure out what the perimeter of the small parallelogram is, because remember the ratio of the perimeters equals the scale factor, so we know our scale factor is 4/3. We could say it's 20/15, it's 8/6, and so we know that's the ratio of the perimeters. Well, we've got the perimeter of the first parallelogram, it's 56. So we set up our proportion, and in this case, I switched my means again, because that does make this easier, because I can simplify 56/4 down to 14, and then that makes it easy. I don't have to simplify once I do my cross product, and I get the perimeter here is 42. I don't have any units, so 42, whatever the units are. All right, our next lesson will be on proving triangles similar, and I think you might find that similar, no pun intended, to finding triangles congruent.